All right, algebra 2. Yesterday or last time we learned about matrices and just like the basics of what a matrix is, and then how to perform operations such as addition and subtraction and multiplying by a scalar on a matrix. So just a quick review, a matrix is just simply a rectangular array of data, and being able to manipulate large rectangular arrays of data can be very important when we're dealing with large amounts of data. Okay, so there's whole fields of study that you can go into that is basically just data analysis. So matrices can be very useful for that. They can also be very useful in such things as computer programming. Okay, so just kind of some applications that may or may not show up in your homework on some word problems. But today, we're going to focus on multiplying matrices by each other. So matrix multiplication is the theme of the day. I want to make it very clear that last time we multiplied by a scalar. You got to keep that straight. Scalars are very simple. You just distribute whatever the scale factor is on the outside, that scalar, you distribute that to each piece inside. Today you're going to see that multiplying matrices is much different. So let's unpack how to do this. The first thing that you have to do before you do anything with multiplying matrices, okay, this is very important that you do this first, is you have to be able to determine what the dimensions of the matrix, of each matrix is, because sometimes if the dimensions don't line up, then we cannot multiply them. So you can only multiply two matrices if the number of columns in the first matrix matches the number of rows in the second. So again, the number of columns in the first matrix must match the number of rows in the second matrix. Okay, so let's figure that out and look at a couple of examples. Okay, so here, how they define a matrix, again, looks like this. We should recognize that possibly from last time, but maybe not. What this is saying is matrix A is a 4 by 6. 4 represents rows, 6 represents columns. It's always rows times columns in that order. Okay, so this is 4 by 6. The second one is a 6 by 2. Okay, so let's go back here. The number of columns in the first one has to match the number of rows in the second one. When they give us data like this, what's really nice is basically the inside numbers must match. Okay, that's what we essentially just said. Columns in the first must match the rows in the second. And in this case, it does. They're both 6. So is the two matrix system defined and can it be multiplied? Yes, it can. Okay, when you actually do the multiplication piece out, what you're going to get is you're going to get the remaining pieces that we haven't really looked at yet. We're going to get a matrix that is going to be 4 rows by 2 columns. Okay, so it's going to be a 4 by 2, and it'll look something like this when we do the multiplication out. Now, I'm not expecting you to understand that fully yet. I'm just showing you how this is going to end up looking, and then we're going to do it. Okay, so for the second one here, again, the columns in the first matrix must match the rows in the second. And in this case, we see that 2 columns in the first, 3 rows in the second. They do not match. So this is just this is not defined. Okay, this system of matrices, if we multiply those together, it's not defined. We can't multiply them together, and you'll see why in a minute. Okay, but those numbers have to match in order for us to be able to multiply. So the very first step when we're doing these is identifying whether or not we can actually do it. So if they give me two matrices, the very first thing that I do and they tell me to multiply them, the very first thing that I do is I actually determine, if I have something that looks like this, and then something that looks like this, let's just even make this a little bit different here. Okay? If they ask me to multiply these together, the first thing that I do is underneath each one, like I might rewrite it, or I might just, you know, just write down on my paper what this looks like. I always do rows first, then columns, right? So rows times columns. So in this case, this will be 2, because these are rows, right? 2 by 4. We see that there's 4 columns, 2 rows. So this is a 2 by 4 matrix. And then my second one has 1, 2, 3, 4 rows. So it's a 4 by 3 columns. Okay, so if I see this, I know that I can multiply because this matches this. And I know that my resulting matrix is going to be a 2 by 3. So what's nice about that is I actually just set it up ahead of time so I know what it's going to look like. I just draw those lines in, and then I perform the multiplication, which I'm going to teach you shortly, and then just fill in the resulting matrix. Okay, so when you multiply a matrix, you guys, here we go. At first glance, it appears complicated, but it's actually pretty simple if you follow a few simple rules. So here it says the element in the mth row and rth row, or rth column, I don't know why they came up with that, of matrix AB is the sum of the products of the corresponding elements in row M of matrix A and row R of matrix B. Okay, whatever. Don't worry about that too much. I want to show you the process. So here we have a 2 by 2 matrix and a 2 by 2 matrix. The 2 and the 2 match up, so we're going to be left with a 2 by 2 product. All right, so first of all, that's what I do. Second, this is just showing you the process. How I come up with my new matrix, or my solution here, is simply this. I take the first, so what I want you to recognize is that this space in the matrix right here, okay, so this is row 1, this is row 2, this is column 1, this is column 2, okay? So that space right there is actually row 1, column 1. So to get the answer to that, I'm going to take, it's always addition here, so we're always adding. We're going to take row 1 and multiply it by column 1, and we're going to add the products together. So that's what you're going to see here. We see that, I'll do this in different colors, we see that we take A and we multiply it by E, and then we got to continue with row 1, right? So we have to include our B. So that's row 1 times column 1, okay? A times E. I'm still in row 1. I'm going to then add that to B times G. Okay, so notice, that's just row 1 times column 1. I'm adding the product. A times E, B times G. Add them together. All right, next. Let's switch some colors here. Let's now go to green. Okay, so, and before I do that, okay, it doesn't matter where you go next in this matrix to solve this, by the way. I'm going to go to this one here, which is going to be row 1, column 2. And maybe when you're first learning this, you write that like underneath this, and then you write the solution to it above, you know, whatever strategy works for you. So row 1 times column 2. I'm going to take row 1 on the first matrix, which is A, times column 2 of the second. In this case is F. Okay, then I'm going to take the second part of row 1, which is B, and multiply it by the second part of column B, column 2 in matrix B. Okay, so I have AF plus BH, which they show you here. All right, then for the next one, down here now I'm in row 2, column 1. So I'm just going to use that as my guide because it does get convoluted later. I'm going to take row 2 in matrix, the first matrix, that's this guy, C, and I'm going to multiply by column 1, E. So I get CE. Then I'm going to add that to the second part of row 2 and the second part of column 1, which is DG. Okay, so notice it's just row 2 times column 1, the sum of those. All right, then finally, I'm going to go to, let's just go to black here. The last one would be row 2, column 2. Okay, so hopefully you're getting this now. Row 2, column 2, we'll go in blue here. So row 2, column 2, row 2 of the first matrix would be B. Column 2 of the second matrix would be F. Sorry, what am I saying? See how this can get so confusing. Row 2 of the first matrix is C, right? This is the second row. Column 2 of the second matrix is going to be this guy, F. So we get CF. Then I take the second part of row 2 in the first matrix, which is D, and multiply it by the second part, column 2 of matrix B, and I get H, so D times H. As you can see, even there, I almost messed that up. So just be really careful and maybe label this and double check it multiple times. And if you're getting the wrong answer, maybe you're multiplying the wrong two things together. It can get a little bit overwhelming. Your calculators can do this, and I'll teach you how to do that in class. But you have to be able to do this longhand, freehand in future maths. So just wanted to make sure you guys have the skill. Example 2 says to find UV if U is this guy and V is this guy. So first off, first thing I'm going to do, 2 by 2 matrix, 2 by 2 matrix. Okay, these match, and then I know that my answer is going to be a 2 by 2. All right, so here we go. I'm going to make my 2 by 2, and then underneath here, I'm just going to label this so we don't get messed up. Okay, so for this one, we are, in this particular place, we are in row 1, column 1. Here we're in row 1, column 2. Here we're in row 2, column 1. Here we're in row 2, column 2. Okay, that helps me figure that out. So for the first one, I know that I'm going to take row 1 of the first matrix. I'm going to multiply that by column 1 of the second. And then we're going to add our product. So here we go. Let's do this. So if we do that, we get 5 times 2, which is 10, plus 9 times 6, which is 54. All right, so I'm just going to show my work and put that there. And then I'm going to do, we'll highlight here in different colors so we don't get messed up. We have row 1 times column 2. That's row 1 of the first matrix times column 2 of the second. Okay, so now let's do that math. So we have, we're just following the red here. We have 5 times negative 1, which is negative 5, plus 9 times negative 5, which is negative 45. Okay, now let's move on to row 2 times column 1. So row 2 of the first matrix times column 1 of the second. When I do that there, I get negative 3 times 2, which is negative 6, plus negative 2 times 12, which is negative 12. All right, notice I'm just using parentheses there, by the way. I'll actually do the subtraction here in a minute. And then for the final one, let's go to, I guess we'll go to green. We have row 2, that's showing up yellow. Let me just do this. Okay, so we don't get messed up. Row 2 of the first one times column 2, erase this here, column 2 of the second. Okay, so negative 3 times negative 1 is positive 3. And then we're going to add that to negative 2 times negative 5, which is positive 10. Okay, so final answer, here we go, guys. We have 10 plus 54 is 64. And then we have negative 5 minus 45, which is negative 50. And then we have negative 6 plus 12, which is negative 18. And 3 plus 10, which is 13. That is the product of the two matrices. Wow, is that all I give you guys? I guess so. So, I think I'm going to kind of restrict your homework just a little bit here because I basically just want you to be able to do that one. For some reason, I have number 10 written down in this presentation, so I guess I want to look at number 10 with you all. So for number 10, I'll help you set that up. Number 10, we have this guy, -4, -1, 3, -5, 2, 4, and we're multiplying that by 2, 1, 6, 8, 4, -1, 5, 3, -2. So first of all, let's see if we can even multiply these. This is a 2 by 3, this is a 3 by 3. These match, therefore I know that I'm going to be stuck with a 2 by 3 matrix. All right, so we have 2 rows, 3 columns. That's going to be what our answer looks like. Okay, and I'm just going to help set this up. I'm not going to do this whole thing with you. But for the first one here, okay, we're in row 1, column 1. In fact, we're in row 1 all the way across here, right? So I'm going to do row 1 across, and then here, this is all row 2. Okay, here we're at column 1, column 1, column 2, column 2, column 3, column 3. All right, so in order to find the products here, notice what we have to do. I think this is why I chose this one to show you, because this is like a little bit more. I think you'll have one that has a few more than maybe just a 2 by 2. A lot of them are either 2 by 2 or 1 by 1, but you might have a couple that look like this. So anyway, for row 1 times column 1, now look, row 1 of the first matrix is all of this. Column 1 is all of this. So I actually am now adding 3 things together. So I just wanted to show that to you, and I'm not going to do the full thing. I'm going to do the first one with you. Okay, so if I do that, I have -2 times 2, which is -8, right? And then I have 3 times 8. So I'm just moving in this pattern. 3 times 8 is 24. And then I have 2 times 5, which is 10. Okay, so if I were doing number 10 on the homework, my first part of the solution to the matrix multiplication would be -8 plus 24 plus 10. And when you do that, you get, what, 34 minus 8, which is 26, I believe. Okay, so some of them you have, you know, more than just 2 numbers to add together. You'll have 3, and I just wanted to show you that on number 10. And again, this can become very difficult to keep track of. So I'm using highlighters to help me with that on an iPad, but if you're just using pencil, you may just want to lightly circle what you're doing and then keep erasing those circles, just so you can keep it all straight. All right, that's all I'm going to say for this. Homework, you should have homework sheets for this, and we'll catch you guys next.